Hello, it's dumplet here. Here's an item on algebra. A and b are positive real numbers such that the square of a minus b equals 4 times the cube of ab. Find the minimum value of 1 over a plus 1 over b. Credits to the Lehigh University High School Math Competition for this item. As usual, pause this video if you'd like to give this item a try. But if you're done, let us dive into the solution. Now here we have an optimization problem, and let's try to make some nice observations. Now one is that the minimum value is 1 over, we want to get the minimum value of 1 over a plus 1 over b. That's something interesting. And the second interesting part is that a and b are positive real numbers. So, well, the first thing I always think of whenever we have positive reals, maybe we want to try using the AMGM. So, alright, if I use the AMGM, this is the term that we want, 1 over a plus 1 over b. That's going to be greater than or equal to square root of 1 over ab. So that's essentially 2 over square root ab. But it's kind of hard to get anything related to ab, at least based from the other given that the other given, the square of a minus b being equal to 4 times the cube of ab. So I think this is probably not the way to go, but we have some nice things that we can kind of take from this attempt at least. Take note of 1 over a plus 1 over b. That's going to be a plus b over ab. And apparently we have a lot of ab's and a plus b. And there is a nice connection between the a plus b and the ab as seen in this one. So maybe we want to rewrite this in terms of a plus b and ab, because I'm pretty sure we can do that via some nice manipulation. So let us try to expand the left side. A squared minus 2ab plus b squared. Now we want to have an a plus b come out, and we have a very nice way to do that. So we can make the negative 2ab over here become positive 2ab and minus 4ab over here. Now the red part, that's going to be the square of a plus b, simple factoring over here. And there we have it, the square of a plus b minus 4 times ab, that's going to be equal to 4 times the cube of ab. So we now have an equation relating a plus b and ab. And this might be helpful because we are going to assign a value to a plus b over ab, which is essentially the minimum value, the expression that we want to get the minimum value of. Alright, so I will make 1 over a plus 1 over b be equal to k for now. Now obviously k is going to be a positive number because a and b are positive. So the reason why I want to make it equal to k is because maybe I can form a nice relationship using this one, because I will technically have an equation in terms of a and b, a plus b and ab. There is a variable k, but that's no problem, and I would be able to incorporate this into this alternate format, and maybe we can get a bound for k, because we're trying to get the minimum value of k. So maybe it is possible for us to get the range of values for k. Anyway, so we have a plus b equals kab, and we're going to substitute the first equation, the a plus b equals kab, into this part, because there's a plus b over here. And essentially, I'll be getting everything in terms of ab. So I'll be getting, if I substitute a plus b as kab, I will be getting an expression in terms of ab. Now, we can kind of treat k as something else for now, and focus on the fact that this part is an equation in ab. Now, a and b are positive reals, so ab is obviously positive. So we can divide both sides by ab, no problem. So k squared times ab minus 4 equals 4 times the square of ab. Now I'll try to solve for k, so I'll be able to get an expression for k in terms of ab. So moving the negative 4 to the other side, I'll get a positive 4 over here. And dividing both sides by ab, I'll end up in this expression. So k squared equals 4ab plus 4 over ab. And this is a very, very familiar case where we are going to use the AMGM. So anything of the format, x plus 1 over x or something similar to that, because we know that the x's are going to cancel, at least in when we solve the geometric mean. So that's going to be the concept that we're going to apply here, since we have an AB and a 1 over AB term. AMGM is probably the best thing to use over here. So applying AMGM into the expression 4AB plus 4 over AB, I'll get that k squared would be greater than or equal to 2 times the square root of the product of 4AB and 4 over AB. The AB's cancel nicely, so 2 square root of 4 times 4, that's just 2 squared of 4. So I would eventually get that k squared would be greater than or equal to 8. And that's going to give me k would be greater than or equal to 2 square root of 2. No worries on the negative numbers here, since we know k is going to be positive. So we can simply take the square root of both sides and don't worry about signs. So k would be greater than or equal to 2 square root of 2. So we've successfully acquired a range of values for k. Now the last thing to check is just to make sure that the value of k, for example, k is greater than or equal to 2 square root of 2. Just make sure that 2 square root of 2 is actually attainable, because there are some cases that we have, for example, k is greater than or equal to 1, but maybe 1 is not possible. It's always nice for us to check the equality case, whether or not if it exists. So since we want the equality case, we're going to make k equal to be 2 square root of 2 and maybe find the values of a and b. So a plus b, let's just set it to be 2 square root of 2. And take note how we got this equality case. It came from this part, which is the AMGM that we did. And by the equality case of the AMGM, the equality should happen when 4AB, or the terms we're taking the arithmetic mean and the geometric mean of, are all equal. Here we have two terms, so essentially just this one. And if we try to solve for AB, we're going to get like AB, the square of AB, it's going to be equal to 1. Again, no need to worry about the negative ones because AB is positive. So AB must equal to 1, and that's the equality case you see here. So eventually, essentially, we just have to find the values of A and B such that A plus B is 2 square root of 2 and AB equals 1. That's no problem because we can easily use the Vieta's formula for this one. So let's just say A and B are the roots to a quadratic equation. The sum is 2 square root of 2. The product is negative. The product is 1. So I can easily form x squared minus 2 square root of 2x plus 1 equal to 0. All I have to do now is just to solve for x, and those are going to be the values for A and B. So let's just check if it's actually possible, because again, A and B are positive real numbers, so I should expect positive real numbers to be the roots of this equation. Now, if I'm going to use the quadratic formula, I'll get 2 square root of 2 plus minus b squared is 8 minus 4ac, that's going to be 4. So square root of 8 minus 4, that's just simply equal to 2. And then we have the over 2 here, so this simply becomes square root of 2 plus minus 1. And both square root of 2 plus 1 and square root of 2 minus 1, they are greater than 0, so no problems here. So A and B would just be a permutation of, it's either A is the bigger one, B is the smaller one, or obviously vice versa. But now that we know that the equality does exist and k can be equal to 2 square root of 2, we're confident to now say that the minimum value of k, or essentially the minimum value of 1 over a plus 1 over b, that's going to be 2 square root of 2. And this will be our final answer. Hopefully you guys learned something new from this video, and I'll see you in the next one. Bye bye!